All right, I want to just run through some quick image processing. If you install um, QGIS through the portal, so if it was installed, um, it would look like QGIS desktop. One of the things that comes along with it is um, the open source Geo for Windows shell. And if I open that, I get a command prompt that looks like this. Now, everything that I'm going to do, I could do in the QGIS GUI graphics GIS environment. However, most of the processing I do, I just want it to be fast and efficient and just, open a file, do something to it, dump it to the disk. At that point, it just becomes a matter of learning what to type. I've got a bunch of files in this folder. We started out with a 6.3 gigabyte image um, from probably from the drone. If I want to get some information about that, I would type gdol info, and that's the input. So I can see, let's go ahead and maximize this. So I can see that, it is a big TIFF file. The georeferencing, this one just happens to be EPSG 6549, which is Ohio State Plain North, US Survey Foot. And we've got the corners. Yeah, the coordinates, both state plane and geographic, and it is has a pixel size, or GSD, ground sampling distance, of 0.0328 feet, which is plenty small. Probably don't need a GSD of 0.032. So there are some things that we can do. I can reduce this file size in a number of ways. First of all, I could just use compression, um, perhaps a JPEG compression, to reduce the file size. The problem is that's still going to be 0.032 foot GSD, and for all practical purposes, that's probably just too small. Plus, if I compress the image, the number of pixels is still going to remain the same. Let's see here. I'm not even sure what the number of pixels is. Let's I'm just going to call up an image, just our image processing software. Let's see, what was that one called? Oh. So that one is 45,800 pixels in both directions. So I could compress it, but when you load that up into a viewing software, it's still going to be 45,000 pixels per side. It may be that that's not an issue. If so, just throw in some image compression, and the file size will get smaller, and that's easier for copying around the disk, but it doesn't do anything for the viewing software. So what I am going to suggest is a combination of different factors. Um, and so in the GDAL processing shell, there are a couple of things that I can do. Let's just look at this text file. So if I look at this line, GDAL translate is the name of the program that I'm going to use. The input is going to be the TIFF file. If it was a 4-band image and had an alpha channel for transparency, which a lot of drone images do, I could strip off that 4th channel and reduce the image size by 25% just by taking off that transparency channel. It may or may not even be in there, but just in case, I always put in, you know, I want band 1, band 2, band 3. I don't want band 4. That's what that 4th channel. If I have 4-band from OSIP and I want to take off the infrared channel, this is exactly what I would do. I would say open up the TIFF file, only give me bands 1, 2, and 3, dropping band 4, which is in OSIP is the IR. Then the next thing I can say is, let's actually just go here and say GDAL translate minus H for help. And somewhere in here has the option for TR, and that is going to be the resolution, the target resolution, and this is going to be in the geospatial units. The geospatial units here are US survey feet. So if I say minus TR, it is going to give me a target resolution of 0.25 feet. The next thing I want to do is whenever I'm radically changing the resolution, in this case from 0.038 feet to 0.25, it has to do some resampling. You can look up resampling images, get an idea of what that's doing. But the thing is, when you're taking, say, 10 pixels and creating 1 pixel, it has to figure out of those 10 pixels, where does the color come from for that 1 pixel? That is called resampling. There are some very aggressive and very high quality resampling options. For the GDAL, you can go to get an explanation, but the options here are nearest, bilinear, cubic spline, and as I go down the line, they're going to get more aggressive and more high quality in the amount of processing. A really good balance for speed and quality is cubic. So I am going to GDAL translate, input this image, bands 1, 2, and 3, target resolution of 0.25. When you resample it, use a cubic. One of the processing options for the TIFF is create a world file. So the minus CO, I can't remember what the C stands for, but it essentially is, the O is options. So I'm going to say TFW yes, output file name. And for this one, I am going to say 0, 0 to 5 foot pixel RGB TIFF. So if I take this command and put it in this, it is going to take these 45,800 and some odd pixels. The speed is in a large part determined by the resampling quality. By going to that cubic, like if I didn't say cubic and just did a nearest neighbor, it would have been much faster, but the quality would have been much lower. So if I just go ahead and start this image in a viewer and I look at that image with a 0.25 foot pixel, this is what I get. If that's good, we're good to go. We can just take that and insert that whole image. If I want to get a little bit fancier, let's add some. So we've got the basics, GDAL translate, input this image, bands 1, 2, 3. This time I'm going to go with a 1/10 pixel, 1/10 of a US survey foot pixel, but I am going to constrain it to a project window because images, digital images, are referenced from the upper left corner and the scanned lines read across and down. The project window is determined here by the upper left and lower right. So I've got upper left XY, lower right XY. So I'm essentially saying, GDAL translate, input this TIFF, give me bands 1, 2, and 3, give me a target resolution of 1/10, give me a project window based on those coordinates. I'm still going to stick with my cubic resampling. I'm still going to stick with give me a TFW. But now, since I've got a lot more pixels in this image, uh, I may want to add in some compression. So I'm going to go ahead and do a compressed TIFF, use the JPEG compression algorithm, give me a relatively high quality compression. Set a JPEG quality of 95, and then I'm going to output it to a 0.10 foot pixel clip RGB TIFF. So that is now my command. It seems confusing, but after about 5 minutes of figuring out what these parameters do and using them over and over again and copying and pasting. So again, input file size 45,000. This time it's giving me a lot more pixels, but it's going to be a lot higher image quality, or I'm sorry, a lot higher image resolution. The quality potentially could be a little bit smaller because I'm compressing, but if I start that image and now say, let's go in and look. We can see that the image pixel size is much smaller. So if I go ahead and open up a drawing that has the image outlines, which I just happen to have here. And let's go ahead and look at that 0.10 foot pixel. And this is the clip outline that I used for that. Because just my personal preference is to see, oops, the pixels. Set this to draft. So those are the actual pixel sizes. And I took a 6 GB image and turned it into a 145 MB image. So obviously if I wanted it a much smaller pixel size, I could just go in and say something like, you know, change this to 0.05 feet, change it to a half a foot. If I wanted just a, something to put on a report cover, I might change it to, 1 foot and get a very tiny image that does exactly what I want it to do. So there we have the uh, QGIS installed OSGeo for Windows shell that gives me processing options that I can just open up that shell and type a command. Keep this handy, make batch files, run it over and over again with different parameters to get an image just exactly the way I want it, hopefully.